Welcome, everyone. Thanks for joining our party. Woo!
It's amazing to see all of you here today. Wow. It's like it's a sea of hair.
Yeah.
Oh.
And who are you?
Sorry. Hi, my name is Dustin Campbell. I am a software engineer on various C# things, a C# language team, C# tooling, cross-platform experiences, all sorts of stuff. And you are?
I am Torgersen. I am a PM on the C#, F#, and VB team. And I'm involved with the evolution of C# as a language. So those are the things we're here to talk to you about. Once again this year, we are happy to report that C# has a future. And we'll try to put some detail on that. So this year, because I'm a PM, they actually said, "Why can you please not go near the keyboard this year?" So actually, Dustin will be doing all the typing.
I actually insisted. As an engineer, I will not have a program manager typing for me.
Yeah. I tried doing a pull request once, and that sort of kind of did it for me.
It wasn't in Markdown, so we didn't make it through.
Right. So let's see. There's probably a clicker up here.
Right here.
Is it okay? It's got two buttons. Is
the
that
green
okay?
one's the one you want.
I could probably do. OK. So every year, Stack Overflow, our friends there, they do a developer survey. They ask people, what do you use? What do you like? In the technology realm, that is. So I wanted to give an update on that, what it looks like this year. And once again this year, we're happy to see that C# is pretty high on their list of the top 10 of most popular technologies, as in most used. OK, so C# is pretty high up there. There are a few above us. There probably remain a few above us. I usually argue one of them is not necessarily a programming language. But, and some of them are languages you use together with others and so on. But no excuses. Hey, it's good to be number 4. That's really good. One thing that I really like to see that's C# there is that there's also a list of most loved technologies, the technologies that people use that they would like to continue to use. Okay, so and C# is on there too. So just being on both of those lists is kind of an honor for us. There's 3 languages that are, by the way, if you contrast, it's C#, it's TypeScript, and it's Python. So that's pretty good for us. All 3 are well supported in Visual Studio, for instance. That's a good thing. So we kind of want to keep it that way, keep C# very highly used, but also very highly loved. So hopefully the things you see today that we're thinking about, that we already put out very recently in C# 7.0, and that we're thinking about for coming versions of C#, they will reinforce the love. It's certainly sent to you with love. So hopefully.
I'm feeling love in this room right now.
Yeah. Yeah, right? Yeah, I wasn't getting that, but now I am, yeah.
Yeah.
So we also want to touch a little bit on sort of the landscape, the context that C# is in. We have 3 .NET programming languages that we as Microsoft are heavily engaged in. There are others out there, but these are sort of the ones that we really push from our team's side. And I want to touch just a little on the state of the world there and how we think about those languages going forward. C#, obviously, used by millions of people today, and in a very, very wide range of different domains. We're actually somewhat flabbergasted to see the range of domains that people use C# for. And so it's a language that needs to satisfy many different styles of programming, many different constraints that you have in your domain. And accordingly, our strategy for C# really is to keep aggressively evolving it so that it will be a satisfying experience, a language that you would want to pick up for your next project. Right? We want to keep it relevant as not just something that, well, we started there, so I guess we've got to stay there, but a language that people would pick up in this vast array of domains. Again, game development, low-level development, enterprise, lots of mobile development, and so on. Like so many different scenarios that it's strong in all of them. So we really have a duty here to keep C# rather relevant in all of those. Visual Basic, used by hundreds of thousands of people. It's still a very, very popular language. It's declining a little bit, but not precipitously. And the set of VB developers is sort of by and large, there are very many exceptions, but by and large more homogeneous than the set of C# developers in terms of the domains that they address. We're talking a lot of line of business applications, a lot of applications built by people who aren't primarily computer scientists or professional developers, but building things for the business, starting out with VB as self-taught and stuff like that. And so for VB, it's important for us not just to throw everything in the kitchen sink in there, but to focus on the features that A, are relevant for those domains, B, are necessary in order for VB to be a fully first-class language when the framework evolves, for instance, like the language features such as tuples that need to interrupt with the framework. And also a language that is approachable for a lot of people. It's many people's first language. And for many people, it's the only language they ever pick up. Like the share of people who come to .NET as their first development experience that use VB is much higher than the VB share in general. So it's important for us to keep in mind. And finally, F# is really a juggernaut and is growing very, very healthily in terms of usage. And it's actually being used, again, in a lot of different scenarios. It is a real it's a real general purpose language, but it's seeing extra strong usage in more analytical workloads, data science, that kind of thing. Have a bit of a math tint to it, and where you have architectures that are sort of very pipeline-y.
And if I might add, I mean, the community around F# is extraordinarily vibrant, like per capita. It's amazing how many people just are giving back to the community there.
So F# is really driven by the community to an extent that the other two languages can only dream of, and has really actually helped us think about when we went open source and doing community and so on. F# was totally like a trailblazer there. And they still are lots and lots of the very cool features you get in the F# tooling and the language itself and so on. They're actually contributed by the community. And our role with F# is to help provide the infrastructure so that the community is able to provide all these different contributions, and also remove any barriers there are to adoption, such as, well, the tooling isn't as good as for C# and VB. Well, let's go and do the work to remove that barrier and make the tooling great.
It's interesting. When Kevin Ransom from the F# team, whenever he comes to stand up, he's like, "What'd you do yesterday?" "Well, I merged 8 PRs."
Yeah.
"Did you write any code?" No, I just merged PRs.
Yeah, he spends all day just merging pull requests from community. We're not kidding. He really is. So F# really great there, and we are expecting lots of great stuff from F# in the years to come. But we're here to talk about C#. So let's talk about the road ahead for C#. We already just released C# 7.0. As quickly as you can, please get into a position where you can use it if they won't let you at work, like do it at home or whatever. It's just so much better. Like it's a whole 1.0 better than C# 6 at least. So
yeah, it's
that's
one
what you
better.
really want to do. And it came out so recently. We're actually gonna recap some of the features in C# 7 here as we do a demo, along with the nice editor work that's there. We're going into the business of point releases. So we've set C# 3.0, 4.0, 5.0, 6.0, all the way up. And we did that for a reason. That's because we anticipated that when we will get to 7, we would start having point releases. So we'll actually start releasing smaller upgrades to C#. And the first one is actually, we're starting in the preview that was released here at Build. It doesn't it only has one language feature in it.
But I only think of this as the second point release, because there was C# 1.2 that most people forget. Yeah, the one everybody forgets. Yeah.
Yeah, that's probably how we got into it. So we think that there will be times where we have some value we don't want to sit on for whatever the period until the next major release. Some stories that need a little fleshing out and so on. We want to feel free to just release a point version of C#. Sometimes there are scenarios that we want to align with in the framework, for instance, that need a little language kind of magic sprinkle on top, and we want to feel free to do that. So we're starting doing point releases, starting with this update 3 that you got a preview of today. There's only one language feature in the preview, but we have more of them working and yet more of them coming, and we're going to touch on that again in the demo. Yes, so there are going to be plenty of demos of this. Then we're thinking there's a C# 7.2, and please bear in mind that these are milestones, and the feature sets for them are intentions. Like, we just want tags to talk about our intentions.
Right.
You can go on GitHub and see us talk in terms of these releases. It's not a promise to you. You can't sue us if we
don't
don't
go
do those
planning
features
engineering schedules around these features being there exactly on a certain date.
But
Makes
it's,
us feel bad.
Yeah, instead of just waffling about it all the time, we just said, let's put some tags on it and be clear about our intentions. And then as all plans change, our plans change too. As we find out something's too hard or doesn't actually really make sense after all or whatever. That happens surprisingly often. So C# 7.2 is where we want to focus more, in particular in the framework and some in the runtime, on we sort of want to push unsafe code out of C# in a way, or more to the corner, having more low-level code that's safe and efficient, more interop with native memory and other things like that. So 7.2 is a language release that has some features that helps with that. It's not for most people, but if you're like a Unity developer, which a lot of people are, that's going to really help you. You're trying not to trigger garbage collections. Well, there's some stuff that's going to be cool. People who are building the lower layers of ASP.NET, Kestrel, SignalR, all that stuff, they're going to build a more robust, more efficient foundation for everyone else to target. And so we think it's worth it, even though there may be some language features that aren't for everyone.
Right. I mean, typically, unsafe is kind of supposed to be kind of an escape hatch when you need to go do these extra things. And now they're kind of becoming fundamentally important for various scenarios, right?
Yeah.
So it makes sense for us to go and do managed ways of doing those things.
Yeah, so we're not going to show any of this today. I'm just telling you that's the plan, that it's coming, and you can go to the GitHub site and see what's rumbling there. C# 7.3 may or may not happen at all. In my head right now, that's where we sort of take the next steps of the pattern matching that we're going to talk about in a bit that we put into C# 7.0. And then at some point, there's going to be a major release. We call it C# 8. It's just a little joke we have. And that's where sort of the major language features, the next major language features are going to go in. And we will show you some of those as well, because we have demos of some of that.
Promise they won't crash.
Yeah, they won't crash at all. So why don't we flip over to your laptop?
Yeah, absolutely.
Dustin, and start looking at some of the stuff.
Yes.
Put this away.
All right. Hope everybody can see that. So I'm going to type. You go ahead. What would you like me to show?
OK, so let's start out simple. Let's get ourselves an array of numbers.
OK.
Let's say they're the powers of 2.
All right.
Which undoubtedly you all know by heart. But
up for a little ways, yeah.
Up to quite probably an embarrassing level. But just to make a point here, it would be easier if we could sort of see, this is binary, right? This is related to binary. If we could sort of see the bit patterns there. So there's refactoring now.
Yeah.
Actually, I think in the preview, right?
Yeah, I believe so. So this was actually contributed by a community member. He really wanted a way to easily convert between bases. And so, yeah, these are decimal numbers. Let's go ahead and we can convert them pretty easily to binary.
Yeah, because binary literals are now in C#. Isn't that cool? Isn't that cute?
Yeah, that's super cute, which is why we added it.
Yeah, because, of course, yeah.
It's why we build features, because they're cute.
Hey, if you're learning programming, or you actually have bit patterns you want to write, well, some of us know hex by heart, of course. But it's actually nicer to. I'm getting old, and I am a PM, so I like looking at the bit patterns directly. Of course, they tend to get kind of long.
Sure.
And so the other thing you can do with these literals is that, and again, there's a refactoring here. Let's stick in some well-placed digit separators.
Separate nibbles.
Separate
delightful.
nibbles, yes, please.
That's delightful. And if you have an enormous hex number, it'll say separate words.
Yeah. We don't have any big enough.
That's why we did it, because nibbles is cute.
Yeah. Cool. So, but enough with this little stuff. Let's call a method to tally these numbers, which means in today's talk, that means let's count them and let's also add them.
Yeah, I'm going to go ahead and use the refactoring to go ahead and bring that.
Yeah, so you can have it generated there. And so the question is, what should we return, the count or the?
Yeah, I want to change this to values. Hold on. There we go. That's better than.
OK, great. Yeah.
Yep.
Should we return the count or should we return the sum? Right. That's always the question you're faced when you have multiple results. How should you do this? Well, now why don't we just return both?
OK. So we can return.
Yeah, it's an int and an int.
Like that.
That's a tuple type. How many of you here dislike tuples? Dislike?
Oh, the hands are well,
not awake.
They just like the error there. Yeah. So for those of you that haven't done it yet, in the options, there is a very important option here, Under C#, yeah, I know it's crazy in here. You could search for it, but I just want to show you where it is if you want to actually direct yourself there. At the very top here, there are a couple of important options that are unchecked by default. These are suggesting usings for types in reference assemblies, suggest usings for types in NuGet packages, and that's especially important when you get started using tuples, especially if you're in an existing project, you create a new .NET Framework project, because this hasn't actually shipped in the .NET Framework yet. Windows has not updated with the .NET Framework with this quite there in essence. So what you can do here is once you've got that on and it downloads in the background, says, okay, I've now indexed a large portion of NuGet packages that are available, the most popular ones, and then I can press Control Dot here, and I can install system.value tuple, so I've got the underlying type just fine.
Yeah, so the gist here is tuples are built on some underlying type. It's not in the existing frameworks. Will be in future frameworks. In the meantime, just get a NuGet package for those underlying types.
Yeah.
All right, so that's pretty cool.
We don't want to throw here. Right?
We don't want to throw. Let's actually at least do a dummy implementation. You can get the default value there.
That's exciting.
That's kind of a little unfortunate.
It is. I especially hate double parens for tuples.
Yeah, the double parens there. Sometimes writing default of something, it's like, hey, that's annoying. I just said it over here on the other side of this assignment. Do I have to say that type again? In C# 7.1, you actually don't. So maybe you can just delete the type there, and you just have target type default expressions. You know?
So this is a brand new feature as part of C# 7.1.
Someone there had that problem.
It's like,
okay. It's okay to express your intent.
But this is an error, actually. So one of the things I've liked about our demos recently is that we haven't had squiggles when we use new language features. This one has a new language, as a new language feature, does have an error. The reason is because this is a C# 7.1 feature, but you guys, I mean, you might be working on mixed teams. You might have projects that are C# 7, and you don't want C# 7.1 features to sneak in there yet because you're still, maybe somebody's using Visual Studio 2017, somebody's using Visual Studio 2015, that sort of situation. So, so C# 7.1 is not activated immediately, but by doing this, we were able to recognize that, in fact, you try to use a C# 7.1 feature, and I get, yet again, another light bulb. And that light bulb tells me that that feature is not available, but it offers me fixes to upgrade the project, to set the lang version property on this project. So I'll go ahead and do that right here. If you grab preview bits today, that actually doesn't work in .NET Core projects yet. It will by the time we push this out to RTM. This is part of the Visual Studio 2017 Update 3 that's out there right now in preview form.
Yeah, so the thing with point releases is we introduced a separation between major and minor releases, and you can set your preferences to the latest major or the latest minor, depending on how much on the edge you want to be. And by default, Visual Studio will come with it's set to latest major.
Yeah.
Okay.
Actually, let's do this.
So,
let's actually make this a tuple here.
Yeah, so actually you have tuple types. You also have tuple literals. So you can write, again, just some expressions, comma separated, parentheses, kind of straightforward there. So we're getting 2 zeros out. Let's consume it. Yeah.
Yep, let's come up here and let's go ahead and, I don't know why I insisted.
What are you whining about?
Why did I insist?
Yeah.
Okay, well, let's use an interpolated string. That's a thing we do now a lot. Everybody's doing this. This is a thing that kids are doing.
There. Yeah, so you see, can you bring up the completion again?
Oh, sure.
Yeah, so what you see is a tuple has, this tuple of 2 has very informative names inside, item 1 and item 2. Okay, so that's great. It means I can get at the first int and the second int. But who can remember? Sometimes I said sum first, sometimes I said count first. Who can remember which is the sum and which is the count? That's hard to remember.
You know, I'm pretty sure that when people raise their hands about disliking tuples, they meant the old system.tuple type where you have item 1 and item 2, right? Those are kind of a drag.
So, so these tuples, it would actually be nice if you could have some names to indicate what you were doing. So let's do that.
Sure.
So we put names on there, and we can actually, so tuple elements can actually have names. Actually, if you go and, can you extract a variable for that, that tuple body there?
Absolutely.
Absolutely. So we got
an expression body right now. This is an expression body because I'm just going to give it a little interjection.
Oh, sure.
Because as part of Visual Studio 2017, we're introducing more of a notion of being able to define your own code style in the product, how you want, where you want squiggles to appear for your style, but also being able to say these are the ways I want code to generate. And I've actually come in here and said that I want to use expression bodies for methods when possible. And so when I pressed the control dot and I brought up the light bulb and generated that, it generated me an expression body. Right now I don't really want that, but I'm going to go ahead, I can fix that. There's a couple of ways. There's one that refactoring, I could just come here and press control dot and say I want to use a block. Or I could come here and I could just introduce a local, which will necessarily have to put a body around it.
Yeah, that's cool.
Yeah.
So now we can, so one thing you notice is a tuple literal without any names converts just fine to a tuple type with a name. But we can also put names directly in the tuple literal.
Yep.
So we can call this, let's call them something else, S and C, for instance,
C,
to make a point. And you see, we're actually, so even tuples have names, but they're not sort of strict about it. You can assign, you can convert freely between tuples with the same or compatible types inside, even if the names are different. They're just really a guardrail. And what you can use them for, oh yeah, let's actually...
Yeah, there's all sorts of ways you can use them. One of the things that actually totally irritates me is when I want to use the same name as the thing that I've been passing around, so I've got to name it and then say it again, or like R and R. But maybe, okay, yes, there I want to give a good name, but when I've got the same name right there, it seems really silly. It's gross. I feel like it's offensive.
Oh, okay, come on.
Okay, sorry. I feel that I feel ashamed.
Okay.
And so...
well, deal with it, man.
I will deal with it. As part of C# 7.1, not in the bits you have today, because software engineering is a real thing, and we have the same problems as everybody else. And we forgot when the snap date was, and so we were ready to check in the date afterwards. But it'll be in the next one, okay? And that is that we will infer member names for tuples from variables or from names that are passed in, so variables or fields that are passed to it.
If you hover on the T
so I can hover and we can see
that
it actually does have the name values, it does have the name R, and those are inferred. So this is part of C# 7.1. Again, we're taking a feature and making it better.
Yeah. Okay.
Yeah.
Now I do want to consume. I want to see on the consumption side what these names are good for. So you see the t.item1 is actually still legal.
Yeah.
Those underlying names are still there, but there's a suggestion up there.
Yeah, there's
smudge.
that little smudge. Yeah. That's what Hunter was calling that, the smudge.
The smudge.
Yeah.
Can you see
I don't think it's marketing approved, but yeah. It's,
okay. Can you see what the smudge is trying to tell us?
Yeah. So the smudge is trying to tell us that we should use the explicitly provided tuple name there.
Yeah.
So because it's coming out of the method as the return type, it says, hey, I should be able to use some right here.
Yeah. And actually, if you pull the completion up again, you can see that we hide the bad names, even though you can use them, and we just show the good ones.
They've been naughty names.
So tuples have a very they have this ability to communicate the purpose of the returned values the same way that you communicate the purpose of parameters when you pass them in. Like there's kind of a symmetry there. You'll notice in all the syntax we chose for tuples, they're kind of similar to parameters, just going the other way.
Yeah, we had this whole long debate, and we went back and forth, and people went back and forth about, like, should they be uppercase and Pascal case like properties or fields because that's what they are, or should they be lowercase because they come back? I've totally settled on lowercase myself. Yeah.
Okay, so that's really good. What do we want to do next?
We should implement tally.
What's that?
I think we should implement tally.
Oh yeah, we haven't actually.
It doesn't actually do anything.
No, it doesn't do anything. Oh, that's a good idea. Okay, cool.
It might be fine for a PM demo, but it's just,
yeah, I thought we were. Yeah, I tipped my hand there. So can you for each of those values then, I guess?
Let's go ahead and fill this out.
Let's do some real work then. All right. Much as I
loops. This is what we do all day.
Yeah, loops. Okay, so we can actually go and we have that R, that return tuple. We can use it as an accumulator, right? We can update it every time around, creating a new tuple literal with the sum of the existing value from it and the
count
and the B that are coming in, and the count gets updated by 1. You can't plus there. You have to +1.
Do I? Yeah, I do.
I prefer that you do.
Okay.
But I think you kind of gave something away there a little bit. That's kind of fun. Okay, so first of all, let's observe here. So people might be concerned, oh, he's creating a new tuple. Is he allocating? Is this bad for performance? And it's not, because that underlying type that we talked about, that tuples are implemented with, it's actually a struct. So unlike system.tuple that you may have used to solve your multiple results problem in the past, these are value types. They are not allocated. They're just like chunks that get copied on assignment. All right, just chunks of memory. If you
Right.
So no allocation was harmed during this But actually,
The heap was not harmed.
so what's funny is that actually not only are they structs, but they are actually mutable structs.
That's true. And I may have accidentally shown that.
Yeah, that's the thing. So actually, you can mutate the elements. So maybe you could do this instead by incrementing the S and the C with proper values.
Absolutely.
Why are you doing it in an assignment?
I don't know. Why is it an assignment? That's because that's what's on the demo sheet you gave me.
Yeah. No, it was not.
Yeah, so I could write it like this. I could totally write all of this.
I'm going to put it up on the web.
I could totally write this, right?
You have C++ in your code there. You need a semicolon. You're F sharper.
Oh, it's okay. And I'm putting
yeah, you could totally do this with mutation because tuples are mutable. Okay, so mutable structs. It's actually even worse. People will go like, oh, mutable structs, isn't that bad? Didn't you tell us for like 10, 15 years that mutable structs are bad? Well, they're bad because of things that can happen when you have function members that mutate. You have mutating function members on there, like methods or properties, and you call them on read-only structs, and they end up happening on a copy, and people don't realize they have a bug and they don't mutate. But we do not have any mutating functions because the elements are not properties because they are fields. So tuples are actually structs with mutable public fields.
Exactly what we told you never to do.
Yeah, and that was
totally cool for us, but don't do it yourself.
Yeah, what were we on that day? What were we?
I don't know.
Whatever we had, as in high demand. But what we had actually was insight. It's like, hey, we're not trying to build some thick abstraction here. Tuples aren't important. It's not the tuples that are important. It's the values inside. We just want a few variables. And so we did the simplest thing possible, which is to just offer up those variables, mutable fields, and that it totally does the job.
Yeah.
So there. Let's see. What do we want to do next? Do we want to?
Actually, one thing that's interesting also about tuples is that it kind of helps an existing problem with async in C#5 that you can't use out.
Yeah.
You can't declare them without variables. So now that I can return multiple values.
Yes. I want to say in general, as he's typing, tuples compose really well with other types. They're just types. They actually have the right value equality that you can use them as keys in a dictionary. For instance, if you want a key on two things in your dictionary, just use a tuple type as the key. And that's all pretty slick. But also, just compose them with tasks in a straightforward way, and that's how you get multiple results back from an async method, right?
Yeah.
Where you can't, for instance, use out parameters if that was how you did it before. They're not allowed in async.
I got rid of most of the errors.
Yeah, so you were... So you made it async. You even changed the name with async, like you're supposed to, but not enough people do.
I'm an engineer. It's automatic.
Yeah, good. But also, so now we're just awaiting and getting the tuple back out. But of course, we're in the main method, which is not async. However,
C#7 again, not in your bits today, but coming soon. Again, remember that our intention with C#.1 is really just to kind of, add a couple of extra features that really enhance existing ones. And so this is one that enhances async. It's been missing for a couple of releases. So.
Yeah, to be honest, 7.1 was like, hey, we got to learn how to do this point release stuff. Take some really easy ones on the top of the list and put them in.
Ask for,
don't have any connection to each other. But async main is great. Like, it's funny because I don't know that many people actually write console apps that are async and ship them. There's probably some, but it's not really. It's just I'm sitting down to learn async. Well, let me start out by, how do I actually start out? How do I get something async to start with as I'm doing my first console app where I'm trying to investigate it? So now just main methods can return task and task of int as well as void and int. And when they do, you're allowed to make them async. And there you go. You can wait from the beginning. The runner knows how to not kill the program until you've awaited the task that gets returned from the main method.
Feels like you want to type. I'm watching it.
Yeah, I'm doing. I don't know what to do with my hands. Yeah, maybe there's a bit of a developer in me after all. Okay. let's back out of the async stuff again. I think, did we cover everything in async?
Yeah, there's a couple more things. There's a couple more nuggets. I mean, there's C#7, we added the value task, for example.
Oh, that's right. Yeah, yeah. So you don't have to return tasks anymore. You can build your own. And the async state machine thingy in the compiler will pick it up. It's probably like, it's kind of hard to do, right? But we built a few for you that, for instance, value task there.
So that you can do this so that you can write asynchronous code without having to allocate.
Yes, value task is really like a wrapping value type for the reference type that tasks are. So if you have the kind of async that where the result is often already available when you await it, then the value task will know never to allocate a task. So it's good for memory-intensive, asynchronous stuff over buffers and stuff like that.
And so one of the big things we did there is really in C#7 generalizing the notion of something that's task-like, right? So that you can go write your own task library if you're, I guess, John Skeet. I don't know who else would.
Yeah, John Skeet would, and Stephen Tobe.
Stephen Tobe would.
Who actually wrote this. Yeah, he did.
Yeah, he wrote TPL, so.
Oh, well. But it's good for the rest of the world that they are there. So
now, something I'd like to show here is often in asynchrony, you want to do this, you want to pass this cancellation token around, when I do that, I'm typing in cancellation token. Let's see, cancellation token. At this point, I've given up because it's not actually in the system threading tasks namespace. There's a different namespace. But by now, I've typed enough that our kind of our fuzzy matching for add using that came in this release has already figured out that, oh yeah, you probably want the system threading namespace and we'll correct the identifier for you. But then also in the preview bits for update 3, if I press space here, it suggests for me a parameter name, which is exactly what I want too, because I hate typing that as well.
Yeah, it just looks at the type and comes up with some good names there.
Yeah, you always want these to be optional, because it's optional. Sometimes you might want cancellation. Not always the case, but sometimes. But of course, this is where the new default expressions really shine.
Now you do that thing again.
That's much nicer.
Great. Okay.
Cool. All right. Now we can back out.
Now we're done with
I don't have any other stuff to show.
Let's take the async stuff away again.
All right. Undo.
Because otherwise things won't work.
The fascinating process of making sure Visual Studio's undo stat continues working.
Yeah.
Excellent.
And then as you're demoing, not going too far.
Okay. Yeah, and they're not going too far. Well, I was watching carefully.
Yeah. So let's come back to those tuples and in particular the consumption experience again up there in the main method.
Okay, in tally, you mean? Right here? This is where we consume, right?
Yeah, actually there. Yeah, so I said you don't actually really care about the tuples. They're just sort of a carrier for the multiple results that you're getting. So it would be nice if you never had to sort of talk about the tuple or talk to it by dotting into it or whatever. Just make it fade into the background. And you can do that with deconstruction, which is another new feature in C#. So there I can say int s, int c, for instance, declaring 2 new local variables and doing it in sort of a tuple syntax on the, the left-hand side of the assignment there. Saying I want to take that result that comes back, whatever it is, immediately deconstruct it and put the elements of it into these 2 new variables, so that down in sum now I can use S for the one there.
It seems kind of silly that I named C.
It's silly that C has a name, yeah, because you're not using it.
No, I'm not using it.
Yeah, you could just discard that.
Okay. Discard that.
So yeah, you can use the underscore now to. If you're doing a deconstruction, you don't care about the thing, just discard it with
That's just in C#7, guys. That's on the box already.
Yeah, you can do this.
Go nuts.
Go do this today. Yeah. And actually, we know what's getting assigned to us. We can totally infer the type of that S that's left there. We can put var in there.
And var in here.
And when you're there where you have like all vars or discards, like 7 of them. No, you're never going to return a 7 tuple. But you can just factor the var out. You mean var it all. All right, so you can do that. Var everything, all right? And so just put names and discards in there. So that's kind of neat. That's a very concise expression of what exactly you want to keep from what comes back from the tally method.
Yeah.
Okay. Yeah, kind of cool. Deconstruction works not only on tuples, but it actually can work on your own types. There's a pattern you have to follow. It's a deconstruct method that you have to add as an instance method or an extension method or whatever you want. Extension method, so I can put it in his types. And then your types can be deconstructed like this as well. Okay, so it's an open feature. It's not just for tuples.
Very similar pattern base that we've done before, like with get-awaiter methods, with the link methods, all of that. Yeah.
Yeah, and as we saw with the value task before, like instead of types being hard-coded into the language, there's a pattern that people can follow and hook into the new language features.
Yeah.
But we're not going to tell you exactly what it is here. Instead, let's go and go crazy with some pattern matching, right?
Yeah, actually.
Oh, yeah, local functions.
Yeah. There's one thing we want to do first, right? Which is, local functions. It came early, so it's easy to forget, right?
Yeah. So so we want to actually, before we go extend the behavior here, we want to factor out an important piece of the logic inside of this method so that we can reuse it in multiple places. So we write a little method that takes that abstracts over the adding more to the sum and the count that we have in scope here, and we're doing that with a local function. So we're just writing a method declaration in the middle of the method, and then calling it.
I can move it anywhere.
Right? And yeah, it doesn't even have to be declared before it's called. So it's just a local. We call them local functions, and as you can see, it has, just like a lambda, it has the enclosing local variables in scope. So this one, for instance, is mutating the R that's outside of it. So that's really nice for helper functions. Is really nice. That you really don't want to expose them even to your other members as a private sometimes. And also that's annoying. Sometimes you have to pass all these parameters that is part of the local state. If you want to mutate it, that's hard and so on. This is just like put it right where you want it in scope of the things you want to edit. So we got a local function there, capturing the essence of adding.
So I've got an idea. You want to talk about pattern matching. So we're going to turn this into.
I'm so stoked about it.
Make this something that's got all sorts of stuff. So make it like an object array.
That's crazy.
It's silly, I know.
Yeah. So let's say that instead of just an array of numbers, we have like a nested array of various things that might be numbers, and we still want to tally them. So yeah, we have to update our tally method to take them, but now we have this problem, of course, that the v that we're getting to is now no longer an int, it's an object. So in old C#,
yeah, you do this, right?
Yeah, you'd maybe like, first check if it's an int.
Go ahead in there, yeah, check if it's an int, cast it to int.
Cast it to int.
Bring it in here
then
like this. Yeah.
Add it, yeah.
But fortunately, there's a smudge.
Oh, there's a smudge?
Yeah, this is just kind of generally what we're trying to do, right? We want to make sure that as we've got this great Roslyn infrastructure in there, we can build code fixes and diagnostic analyzers and do all these great new tooling features. As we build the language, we're looking for opportunities to spot ways that you could use new language features. You could write code, in a newer style, maybe briefer, more concise, that sort of thing. And so here it's suggesting to me to use this feature, pattern matching.
Yeah, well, do it.
Yeah, done.
Yeah, woo. Okay, what just happened there is that the local declaration went away, and instead the is expression changed a bit. Instead of saying v is int I, it says, v is int. It now says v is int I. So what it does essentially is, as it's checking that v is an int, when it knows it is, we might as well grab it and give it a name. Like here's the int I, that's the value that was in v that was an int.
Yeah.
Okay, so that's what it means. Yeah.
Mind's blown.
So you all have that. You either use is and cast, and you hate doing two casts, or you use as and you hate checking for null. And, this just packs it all into one. But the int I there is something special, right?
Yeah, you can do other things here. I mean, it's a pattern, right? So I could put there are different kinds of patterns.
So it's important to note that int I in itself here is a new thing in C#. It's a pattern. We don't have patterns in C# up until now, but here they come. This is a type pattern. Patterns are things that can essentially test a value for a certain property, if you will, and also extract information from it as it's doing so. And they're known from functional languages, like F# has lots of patterns. We have a few. There's a type pattern there. There's constant patterns. You can write null or an int literal or string literal, things, constant expressions. You can check if the thing is equal to that, essentially. So constant patterns as well.
So we're probably, because we got like all these objects. We've got all sorts of values up there. We're going to have to do like a big bunch of else ifs.
Yeah, so first I wanted to change it back, by the way.
Oh, sure, yeah.
To int I there.
Offended you.
Yeah, we could do this with else ifs and a lot of is expressions, but since we're checking v all the time, it's like everything's about v here. Why don't we just switch on v?
Okay. Switching on an object, which was not something I could do.
Yeah, you couldn't switch on anything that wasn't like a primitive or a string before, but now you can switch on whatever you want. And your cases can have patterns in them, right? What you didn't know, what we actually didn't know, was those cases that you had all through C# 1 to 6 were actually pattern-based switches on constant patterns. We just didn't know it at the time. But
we tried it, and it was just,
yeah, but now that's what they are. Like, constant patterns are just a special case here of course, cases are on patterns. So you can say case int I. If the thing is an int, give it the name I, and in the body of that case, you can use I. Just like we saw before with the if.
There's a bunch of others up there. We should, there's like an object array at the end.
So we want to deal with the object array.
Let's
implement
we can do that in terms of itself, right? So we can call, recursively here, we can call tally with the object array.
Yes. You call the method again on that object array. You get something out, you add it to what we have here. All right, recursively going in.
It seems the engineer in me says that's inefficient, that I should be checking the length. I shouldn't be calling off to members if it turns out that there's nothing in there.
Yeah,
right?
Good
so
idea.
I want to check when length is greater than 0.
That's cool. Yeah, of course, cases have conditions, right? They have Boolean conditions and the stuff you got. They might not want to go here now. Of course, now we still have those empty object arrays.
The empty ones we just need to check, but I don't.
But we can use a discard.
Yeah, I don't care
because
about
we don't
those.
actually care about it. We just want to say skip that one. All right.
Cool. There's also the case that somebody might pass in null, right? We want that.
Oh yeah. We want to skip those as well, don't we?
We can use a default. Like
we do need a
nothing
default.
To handle.
Let's throw an exception. If the thing that comes in can't possibly be interpreted as a number, let's throw an exception. So one thing you notice here is that it didn't used to be the case that switch statements were order dependent, but they are now actually. Actually, they always were. It never mattered. So there's no breaking change here.
We could always put this anywhere.
Yeah, the default always is executed last.
Well, sort of anywhere.
But you should put it last.
I want to put it right
clarity.
here. Is that cool?
But it's like, oh come on. So it's like with with catching exceptions, right? You execute them in order. The first one that fits, you grab. And so there's sort of just when you see, oh, this is an object array. Let's try this one. Then you try the condition. It didn't work. You go on to the next one, and it gets caught there. So now order matters in switch statements now. It's worth noting.
There's one other type here we aren't checking for. That's the string. I'm passing 42.
Yeah.
Because that's like important number.
How are we going to deal with that one?
Well, we're going to have to, again, it's going to be a pattern thing, right? So we can say case string s. We're going to have
we
to
can try parse it.
Sure. Okay.
Yeah, in a when clause.
Try parse s. This takes an out parameter. So I have to do something like this, right?
Yeah.
What kind of stinks about that is, and so I can do it down here.
Yeah,
say we're going to add I, and well, I haven't declared I, so IntelliSense is fighting me. Oh, it's misery.
Oh, because
hold on, and I'll finish this. Up here, I'd have to declare it outside the switch.
You have to go all the way out there to declare the I. That's really
that is
annoying, man.
Again, it's offensive, right? I keep saying that, but I really feel deeply offended by this one.
Yeah.
Fortunately, there's a smudge to help.
Oh, smudge to the rescue. This is called smudge-based programming.
You know, in a smudge-based programming, SPD.
Yeah.
SPD. So in the last release where we did C#6, we had Visual Studio 2015. I wrote an extension called C# Essentials that had a whole bunch of code fixes and analyzers for dealing with new language features. We just jammed them all in the product, right? So those are in here now, and then we've added more. So this smudge, in fact, lets you know that you can use the new outvar feature.
Outvar. Out variables.
Right, so I can say inline this variable declaration, and it goes all the way down into there.
And it puts a variable declaration right in the out argument there.
And
so
the
you're
great
declaring
thing,
a new variable?
Yeah. One of the other things that's interesting about this is that before, I'm gonna go back, and it might not have been obvious, but this actually bumped up against one of those rules in the C# language around switch that everybody kind of hates, but it's like a major breaking change to do anything about, so we're never gonna. The fact that right here, this I conflicts with that, right? So there's a squiggle. By declaring it in line here in the outvar, that's not a problem anymore. So I can reuse these variables in those cases.
Yeah,
that's pretty cool.
Very cool. And of course the out parameter there, you could also actually, if you don't care about it, but you just have to pass something, and you know the dummy that you always have to declare and pass in as an out parameter you don't care about, you can use a discard again, of course, there as well.
Yeah,
discard
it's just a pattern, right?
Yeah.
So
there are all these places where variables can now show up in expressions.
Yeah.
And in those places, you can you can often now declare the variable in place, like in the is expression, like here in the out position. We call those expression variables, and there you can typically also use the discard.
Yeah.
Okay.
All right. Well, I think we're done with the C# 7, 7.1-y kind of stuff right now.
Yeah. You had a few IDE things you wanted.
I want to show a couple more IDE things. I've been trying to sporadically, assert myself over Mads, who tends to dominate these talks.
You got 5 minutes, man.
And it's okay.
5 minutes.
All right,
I
fine.
want to
I'll
be
go
back
quickly.
in charge.
So a couple of things I'd like to point out. We're doing a lot of investment in the IDE, trying to make the C# experience as good as we can make it. Also, just because, look, we all know a lot of us are installing products to kind of augment the C# experience, right? And there's a lot of that we feel kind of embarrassed about. Like there are features there that really should be in the box, and it kind of feels weird that you have to go get in our product. So we're making a lot of those in the box. And so there's a couple of features I want to demonstrate as we get going here. One of them is the lines that are connecting the braces. That's not an add-in. That's not the Productivity Power Tools. It's something that was in the Productivity Power Tools, but we brought it into the product, and it connects those braces so you can line that up visually. Right? That's new in Visual Studio 2017. Something everybody forgets to mention is that you can hover over these things, and it shows you kind of the structure of what those braces kind of, as you would pop out to the blocks outside of that, the structure of what you're looking at. So if you're way off screen, you can look and say, oh yeah, that's that switch, that's F4 each, all the way up. That's pretty cool. Something else we've also done in this release is try and put kind of a new skin on existing features. So like find all references. Back in, I think, 2015, we shipped it, and it had like a big flat list. And then we, at the last second, did a thing so we could at least group things and kind of nest them. But this big flat list of all references was really hard to visually kind of separate and see what you're looking at. So we went grouping, and then this release we went a little nuts, and we made it so that you could that it would actually be colorized and show. It was just a much better presentation. So if you're on a large solution with references all over the project, you can see where things come from. You'll notice that at the top there's a group by that you can actually change, how you want these to be visualized, how you want them to be grouped. In the update, because we're a little silly, but it's actually an interesting feature, we added it so that you can do final references on literals, right? So on literal values. So right here, I'm on the number 1. If I want to see where the number 1 is used throughout, I can put final references on there. Notice that it finds the binary 1 too, which is kind of cool. Yeah. But yeah, it's just a nice little feature. It's in this new update 3 that's coming. You wanted to clap for that, for finding the number 1. So.
Well, it's good.
I mean, it's a thing, right? So so now we can grep with Shift F12 effectively. I'm going to go and
it's good for those like magic constants, right?
Yeah,
you
totally.
You want to find them and factor them out or something.
Let's see, I've got some other demos I want to show. So I'm gonna switch over. Well, first I want to get rid of this junk here. So let's kill the stuff we've been doing. I'm going to kind of roll back here. One sec.
The joy of...
Yeah, isn't that fun? This is engineering, Mads. This is what you do
this
all
command line
day.
interface. That's because you guys just totally rock that.
Yeah, it is. It is. So I'm gonna check out a branch I've got for doing IDE demos. Also, when I was looking in here, there was another branch I wanted to use. It was this one right here.
Branch. Yeah, I can see why you want to use that.
Yeah, I do want to use that. So
I'd want to use it too.
Well, first, let me come back here. I want to see, because I'm just kind of getting myself first to a clean slate. And let's go ahead and merge that awesome branch in. Okay, awesome branch.
I can't wait.
Though there's a merge conflict, and that is also what engineering is all about.
Yeah.
So there's a merge conflict. Now, this is a feature we haven't talked about much, but it's super useful, and it was championed in by one of the developers on the team that really, really loves this feature, and it's fantastic. But the idea here is that it actually required us to do some parser changes to be able to kind of recognize these tokens for these markers that represent merge conflicts, right? And so it gives us squiggles on these. They're actually colored now as comments, and so it's not just like your code's not going completely crazy, and it tries to continue, limping along. But also, we added a code fix to be able to say, do I want to take head? Mm-hmm. Do I want to take awesome branch? Or do I want to take them both? I don't want to take them both. I kind of want to take awesome branch.
Yeah, I think you should.
Yeah, okay. So that's a brand new feature that's in 2017.
It's that's really cool. It's one of those examples of being, right there in the code, doing more things right in the code instead of having to go.
Totally. Now, I'm going to go ahead. I want to show a feature, but I have to type a bunch. So
Okay.
I'm typing a super long string right now.
Yeah,
That's
I
going to
see you
go
are. Okay.
all the way
Okay.
to the right.
Yeah, I wish you'd
Math
use the
seems
I wish you'd
uncomfortable.
use a bigger font right now, because this is kind of taking a lot of time, Dustin.
Well,
Oh.
it's amazing. I've typed as well.
Uncomfortable is a mild term for what I am right now.
As I am.
Hey, we're on stage. It's like, I don't know, like
it's
40
true.
people watching us.
Yeah, I guess I'm under pressure.
Yeah, okay. Okay.
Okay, so yeah, so that was sufficiently long. Again, just a small little feature, and it's as we have this Roslyn infrastructure, and it's easier for us to either take contributions. If you feel passionate about a feature, go over to the github.com.net Roslyn and submit a pull request. Or somebody just feels passionate, they just want to go hammer something in overnight. And this is the one. So I just come in here and I press enter, because I don't want to see this like that. I want to
Just pressing enter, guys.
Concatenation. And
Like, I could be a developer now. Just press enter, right?
give me one more, and then we'll move on to C#8. So,
Yeah.
So I'm going to declare a type here. I am actually, because I'm a big geek, and I'm not as comfortable with normal money. I spend it immediately. But this is something I'm super comfortable with, right? And so I'm going to declare a value to be able to do this. RPG?
Isn't it a developer thing?
No, that's a nerd thing. Talk to me afterwards. I'll get you to turn your nerd card back in. In this form of money, we have platinum. And so I'm going to go ahead. Now, I declared a constructor for this. I'm adding a parameter. And some of those nice little features that you tend to use other tools to do or help to do or write snippets for, again, we're putting them in the box. So pressing Control Dot here will now allow me to create and initialize a property for that immediately. And so I can go very quick, right, filling this guy out. I can even come up here now, and well, this is a value type, and if anybody's created a proper value type that actually handles equality and all that, it's kind of a pain. So I'll come up here and I'll use some helpers for that, generating equals and get hash code, allowing me to pick the members I want. I want them all, and I come down here and it's
look at that hash code implementation.
It's what the heck is this number?
It looks totally
crazy.
random.
It looks random. Yeah. I'm going to introduce a constant for all occurrences, because that is silly. That is magic. But it's also
there was one.
If I convert it to binary, it doesn't look like it's actually all that random.
Oh, wow, look at that.
That's kind of amusing.
It wasn't that random after all. Can you put some separators in there?
Oh, yeah, sure. Separate the nibbles.
Yeah, look at that. It's 10, 10, 10, 10, 10, 10.
It's not that random.
I
don't know what this number is.
Whoever
but
wrote this used hex, I'm sure.
I feel that we might
It's a
need
hex A right there.
I'm not sure this passed code review. Okay, so that's enough IDE stuff.
Yep, okay.
Let's talk about what they're actually here for. They've been waiting like 55 minutes.
Yeah, now we have 7.5 minutes left to talk about next major release of C#, affectionately known as C#8.
Yeah.
We have a few prototypes of features we are hoping to put into C#8, and we want to show them to you. Yeah. What do you want to do first?
Hold on, I gotta get out of here. It's dev work. I'm sorry.
Oh, okay. Just go ahead and dev while we're doing a talk. So I think we want to talk about default interface implementations. Is that
what?
One that you're pulling up?
In a sec.
Yeah, that's one, because I just want to lead in to the right feature that you're going to show.
Actually.
So the thing here is, interfaces sometimes, sometimes there's just a thing that the way that everybody implements an interface method. Also, more importantly, evolving interfaces is really hard, right? You can't if you add a new member to an interface, you're breaking everyone who's already implementing it. And so essentially, you're stuck with your interfaces forever and not being able to add new stuff.
Right. So we've got something like this. Now, this is pretty simple, right? I've got an interface that has a method M1. I implement that on a class. And if I run this, you can see down here that I create a new instance of C1, and then I call M1 through the interface, right? I've cast it. I've ensured that it's implicitly converted to the interface. And that should work pretty well. But, it's such a simple thing. What if I could do this?
Yeah, just implement it on the interface.
Right, and so then I can press F10, which will build and start debugging and let me step in.
It's going to say that it's still running in C1, but that's because your interface is printing C1 out.
Oh yeah, it will. It'll say that. I can fix that actually. So I'm going to step in, and it actually calls in the interface. I'll go ahead and I think I can edit and continue.
You're going to edit and continue in this prototype?
In a prototype. I am crazy.
Yeah, you are.
And so, sure enough, that's
cool.
what it did. Yeah.
Okay.
That works.
Yeah.
I'm stunned. They're not all that impressed. The idea is, so.
No, I think the big value prop here is, so there are a couple of value props. The general value proposition here is that you can now add new members to interfaces as long as you give them a default implementation, because then all the existing implementers, they can just use that default implementation. They don't break.
Right.
Okay? Well, as long as that does something sensible for everyone.
Here's a good example, right? So I've got a logging interface here, right? This is the sort of thing where you're like, okay, this is an interface that if I wanted to add a member to this, and I wanted some of them, I wanted to be able to implement that member, that would be a breaking change to all the potential loggers out there, right? And so I've got a console logger, I got a telemetry logger, but what if I wanted to add one that took an exception, right? Well, I could do that. I could add it here. This would be a breaking change for everybody right now. They would all have to go implement that. Okay? And you say, well, you could do this with an extension method. Sure.
You see the red squiggles show up.
The red squiggles there, yeah. So you actually see it showing up.
Yeah.
But if I go and add a body for it, and I can do this by calling the log that I have here already, and we can just pass toString and give it kind of a default implementation, we're good. Now again, this is something I can do with extension methods today. But the thing I can't do with extension methods is to have specialization on one or more of the implementers if they want to. This becomes something that's a little bit more optional. Go ahead and implement this without having to do something like add an iLogger to interface or something like that. So I could come down here and say void log error, or it's just log, right? That's what I call it? Yeah, with an exception. And now this is the one that will get called if the instance happens to be this. And so this is where it becomes much more interesting than doing an extension method, because then I might want to say, well, capture crash dump and send message because it's my telemetry logger, for example. So this is the main value prop, or a big value prop, not the main one, but a big one.
So while you go queue up the nullable thing, one thing to note is, so other languages already have this feature. Java has it, Swift has it, and funnily enough, those two languages are the languages in which the APIs on Android and iOS are exposed, and so we like to wrap those for Xamarin. And right now we can't faithfully wrap APIs that make use of this feature, that have default implementations in their interfaces. And so very concretely, this is going to go and solve that problem, make it much nicer to wrap APIs that are actually from other languages originally, and have a smooth, nice interface on the C# side or on the .NET side for Xamarin.
Okay, the last one. This is actually, I have two shortcuts on my desktop. I have one that says medium hot VS Bits. This is super hot VS Bits, okay?
Yeah, blazing hot.
Blazing hot. I could not change the icon to have the little flame, but that's, sorry about that. But the idea here is I've got a database that I'm loading some text from, right? And I just want to count lines with, in that text with the character X, okay? Use the correct variable name, solves all problems. But it doesn't actually solve the problem. There's actually a warning right there. And that warning says there might be a possible null reference argument for the parameter text.
What's that about?
What is that about? What's happening here is my load text method has said, hey, the thing that comes back here, it's possible that this could be null. If I hover over it, you'll see, in fact, that it's defined as string question mark. Okay, meaning I can annotate and say, this is something that could possibly be null. And so now I have a possible null reference because this also does not say it can be null. So I can come down here and I can declare this reference type as nullable, saying, now I accept null here.
Yeah, essentially you have a choice.
Yeah, you do have a choice.
It's going to help you deal with your null reference exception to compile time.
I could also do this.
You can choose to either check for null first, and the compiler will say, all right, we know it's not null. You're free to pass it
Actually,
along.
wrong way.
Or
there we go.
You're doing it there, right?
Yeah, I can do it that way.
Actually, so there's a flow analysis here saying he checked that thing was not null. We will allow it to be passed as not null.
Yeah.
Instead of introducing some new way of checking for null in the language, we just recognize the ones you're using.
Now down here, I'm going to get a null dereference right here saying this is possibly null. So we could come in and say, well, if text equals null, then we'll do that special case of just return 0 because we know they haven't found any. So this is a way that we can help you as you're writing code to not write so many of those darned bugs.
Yeah, so the core of that feature is giving you syntax to express your intent. Is this thing supposed to be null? Well, in that case, protect it against being dereferenced until somebody checked that it isn't. All right, is it not supposed to be null? Well, in that case, protect you from putting null in it or from leaving null in it as a default value in a field or whatever.
Yeah.
So that's the idea of the feature. Give you annotations that you can put in your code, give you warnings when you don't act according to those annotations.
Yeah.
And that's, so we call them nullable reference types.
Not non-nullable reference types?
Yeah, well, it's sort of, the rest of the reference types then you can sort of think of as non-nullable.
Okay, I had a triple negative there, not non-nullable.
Not non-nullable, no.
Okay, yeah.
Okay, we're down to the wire.
Yeah.
Can you flip back to slides quickly?
Those were
time is
super
officially
secret,
up,
guys.
so if you're on the live stream, bye-bye. I just want to mention very, super quickly another few features we're thinking about for C# 8. So there's the next step of async, which is essentially dealing with streams of events or data that are essentially asynchronous, allowing you to for each over those and have like your await nice code like you have with await on single values today. Also, sometimes your disposal needs to be async. Well, maybe we have an async disposable that using recognizes and will await the dispose to finish. We have extension methods since C# 3.0. Maybe we have some way of doing extension other things, including properties, all kinds of static members, operators maybe, constructors. Can we generalize to extension everything? That'd be really cool. And it's very frequently asked. Also, Dustin had a type before that was very value-based. All the defaults of C# in essence are wrong for when you want to have immutable value-like types. Well, what if there was a syntax where you could just have that be the default, like records in other languages, and that would just generate all that equals and get hash code and deconstructors and constructors and whatnot from that very simple thing you wrote up there. So those are some things that we are thinking about as we're going forward. Here's some resources. You can take a quick picture and go, for instance, engage with a language design process on GitHub if you want to, and throw in your 2 cents.
Yeah, and just one word, I also want to mention that what we put up there is C# 8. That article you're about to go write that says all that's in C# 8.
Yeah,
maybe.
It might be wrong.
It might be totally wrong, yeah, so just beware.
This is intention.
Yeah, the intention is these are the things we're talking about and working on right now that would go into a bigger release.
And now our intention is to wrap up here.
Yes.
And if you want to talk more, we're going to head down to the booth, the C# Visual and Visual Basic and F# booth that's hidden somewhere in the corner in the expo. If you don't catch us there, we're on Twitter, so is Roslyn. And so thank you very much for coming. Thanks for sitting nicely, and see you next time.
Thank you.